I am initiating this log to keep my mind sharp, not because I expect anyone to read it. The sun has just crested the ridges to the east, and already the aluminum skin of this C-1019 flying boxcar is beginning to groan. It is a specific sound, a low-frequency moan of metal expanding under the thermal shock of the Nevada morning, distinct from the sharp cracks the fuselage makes when it cools down at night. I am sitting at my workstation, which consists of a repurposed navigator's table bolted to the ribbing of the airframe. The air inside is already stale, carrying the permanent, heavy scent of old canvas, dried hydraulic fluid, and the copper tang of the electronics I have stripped from the surrounding wreckage. My hands are steady, but I can feel the vibration of the heat rising through the floorboards. This aluminum shell is my armor, but it is also an oven. I have spent the last hour checking the insulation seals I installed using seat cushions from a commercial airliner wreck 3 miles south. If even a single seal fails, the dust gets in, and if the dust gets in, the equipment dies. The silence out here is heavy, almost having a physical weight that presses against your eardrums. It is not the quiet of a library. It is the absolute absence of the mechanical hum that used to define the world before the pulse. There are no distant highways, no jet engines overhead, no 60-cycle hum from power lines. The only sounds are the ones I make or the ones the wind makes. When the wind dies down, the silence is so profound that my ears create their own noise. A high-pitched phantom ring known as tinnitus, which serves as a constant reminder of the isolation. I have to consciously regulate my breathing, because the sound of my own lungs filling with air seems aggressively loud in this confined space. I take a sip of water from my canteen. It is warm and tastes slightly metallic, a byproduct of the condensation system, but it is clean. Hydration is a mathematical equation here. Output must match input, or the kidneys fail within 2 days. My primary task this morning is energy management. I move to the rear of the cargo bay, where I have rigged the generation system. It is a crude but effective setup. A stripped-down bicycle frame welded to a mounting bracket, with the rear wheel replaced by a belt drive connected to 3-car alternators I pulled from a line of dead trucks. This is strictly mechanical physics. There are no microcontrollers to regulate the charge, just raw kinetic energy converted into direct current. I mount the seat and begin the rhythm. It takes significant torque to get the alternators spinning fast enough to excite the coils. I can feel the resistance in my quadriceps, a burning sensation that tells me the battery bank is accepting the charge. I have to maintain a specific cadence. Too slow and the voltage drops below the charging threshold. Too fast and I risk overheating the bearings, which are already worn from years of neglect before I found them. While I pedal, I watch the needle on the analog voltmeter mounted on the wall. It wavers slightly with each rotation, hovering just above 14 volts. The bank consists of 12 lead-acid batteries linked in parallel, scavenged from the oldest vehicles I could find in the yard. Newer batteries often had internal monitoring chips that fried during the event, but these heavy lead blocks are purely chemical. They are heavy, inefficient, and prone to sulfation, but they work. I have to keep them cool, so I have positioned them near the floor where the air is densest. The rhythmic whir of the belt drive is hypnotic. I count the rotations to keep my mind occupied. 1,000 rotations is usually enough to top off the charge lost during the night's radio watch. My sweat drips onto the metal floor, evaporating almost instantly in the dry air. I am part of the machine now, the biological component that keeps the electrical heart beating. After 40 minutes of cycling, the needle stabilizes, and I dismount. My legs feel like jelly, but the green LED on the charge controller, a simple resistor diode circuit I soldered myself, is glowing steady. Now comes the most delicate part of the morning routine, the dust patrol. The alkali dust of the Nevada desert is not just dirt, it is a corrosive substance that eats through copper contacts and shorts out circuit boards. I pick up a soft brush made from camel hair, originally a lens cleaner from a camera kit, and begin the slow process of sweeping the radio equipment. I have to be gentle. A single aggressive stroke could dislodge a wire or crack a brittle solder joint. I work my way across the face of the main receiver, cleaning the knobs, the dials, and the glass faces of the gauges. The dust is everywhere, a fine white powder that settles in every crevice. It is an endless war of attrition against entropy. The centerpiece of my setup, and the reason I'm still alive, is the transmitter. I call it the Frankenstein, because it is stitched together from the corpses of a dozen different machines. The chassis is from a 1950s ham radio, but the internals are a mix of military surplus and civilian aviation parts. It runs on vacuum tubes, or valves as the British called them. They are glass bulbs containing a vacuum and metal filaments, technology that predates the silicon chip by decades. Because they rely on thermionic emission rather than semiconductors, they are immune to the electromagnetic pulse that wiped out the modern world. I inspect the main output tube, a glass bottle the size of a fist. It has a hairline fracture near the base. I hold my breath as I brush the dust away from it. If that glass shatters, the vacuum is lost, and the transmitter becomes a useless paperweight. I have no replacement for this specific tube. I step outside the fuselage to check the solar array. The heat hits me like a physical blow, instant and oppressive. The light is blinding, reflecting off the sea of aluminum skeletons that stretches out in every direction. Hundreds of aircraft, from old propeller fighters to massive cargo lifters, sit in silent rows, their paint stripped by years of sandstorms. I have positioned my solar panels under the wing of the C-119 to shield them from the direct midday sun, relying on the reflected albedo light from the desert floor to generate power without cooking the photovoltaic cells. I use a rag dampened with recycled gray water to wipe the surface of the panels. Every layer of dust reduces efficiency by a measurable percentage. I wipe them in straight lines, maximizing the surface area exposed to the glare. My eyes scan the horizon constantly while I work. The shimmer of heat haze makes it hard to see distant movement, which is dangerous. Returning inside, I seal the hatch. The temperature difference is noticeable, though it is still hot. I move to the water reclamation unit. This is survival plumbing at its most basic. I have rigged a plastic tarp under the roof of the fuselage to catch condensation, channeling it into a filter made of charcoal and sand. But my primary source is the urine recycler. It is a solar still setup. The liquid evaporates in a sealed container, leaving the toxins behind, and condenses on a clean surface to drip into a collection jar. I check the levels. It is a slow process, yielding only a few liters a day, but in this environment, water is more valuable than the gold contacts in the avionics bays. I inspect the seals on the evaporation chamber. A leak here would not only waste water, but would fill the bunker with the smell of ammonia. The system is working, evidenced by the slow, rhythmic drop of clear water into the glass jar. I sit back at the radio desk and put on the headphones. They are heavy, rubber-padded military surplus that blocks out the sound of the wind outside. I flip the toggle switch to warm up the receiver. It takes about 30 seconds for the tubes to reach operating temperature. I watch the filaments inside the glass bulbs glow a dull orange, a comforting warm light in the shadows of the fuselage. Then comes the sound. Static, a wash of white noise that sounds like rain on a tin roof. This is the sound of the universe. I slowly turn the tuning dial, moving through the frequencies. Most of the spectrum is empty, just the hiss of cosmic radiation and atmospheric disturbances. I am looking for patterns, for the rhythmic modulation that indicates an artificial signal. My hand moves the dial with practiced precision, listening to the texture of the static. The antenna farm I have constructed is hidden to the casual observer. I have run copper wires along the existing cables of the aircraft graveyard, turning the dead planes themselves into massive, passive repeaters. My main dipole antenna is strung between the twin tail booms of my C-119, almost invisible against the metal structure. This setup gives me decent reception, but transmission is risky. Every time I transmit, I become a beacon in the electronic dark. Today, I am only listening. I scan the lower frequencies first, the bands that hug the curvature of the Earth. Occasionally, I hear the ghost of a signal, a burst of static that sounds structured, but it usually fades before I can lock onto it. The ionosphere is a fickle mirror. It reflects radio waves erratically depending on the time of day and solar activity. I decide to check the perimeter defenses. I do not use cameras or motion sensors. They are too complex and require too much power. Instead, I rely on geology and acoustics. I have buried empty coffee cans at 4 cardinal points around the aircraft, about 50 meters out. Inside each can are 3 glass marbles. I have run a stethoscope tube, simple rubber hosing, from the bottom of each can, underground, back to the fuselage floor. It is a primitive seismic detector. I unplug the stethoscope from the port marked north and press the earpieces into my ears. I listen. If anyone walks near the can, the ground compression will cause the marbles to shift. creating a distinct click that travels through the tube. Right now, I hear nothing but the deep, low-frequency groan of the earth heating up. It is a dull thrum, distinct from the sharp click of footsteps. Hunger is a constant background sensation, a dull ache in the center of the stomach that I have learned to ignore. I open a can of peaches from my stockpile. The date on the can is 6 years old, but the seal is intact. I eat slowly, savoring the sugar syrup. Food is fuel, nothing more. As I eat, I review my inventory list written on the metal wall in grease pencil. Batteries, stable. Water, critical but manageable. Tubes, one spare for the rectifier, none for the output. This is the weak link in my chain of survival. If the output tube fails, I lose my voice. I can still listen, but I cannot shout. The thought gnaws at me. I have scoured the immediate area of the Boneyard for replacements, but most of the avionics here were solid state, filled with useless chips. I need equipment from the 1950s or earlier, and that is becoming harder to find. The afternoon sun is at its peak now. The interior temperature of the fuselage has climbed to 40 degrees Celsius. I strip down to my undershirt. The heat makes every movement an effort. I spend the hottest part of the day doing stationary tasks to conserve body water. I am currently soldering a new connection for the battery bank, replacing a wire that showed signs of corrosion. I use a butane torch instead of an electric iron to save power. The flame hisses softly. I heat the copper wire and the lug until they are hot enough to melt the solder on contact. The smell of burning rosin flux fills the air, a sharp pine-like scent that I find oddly comforting. It is the smell of repair, of fixing things. I verify the bond is shiny and smooth. A cold solder joint would add resistance and waste energy as heat. I need to conserve the butane, so I work quickly. Once the connection is solid, I wrap it in self-fusing silicone tape. This tape is the only thing that stands up to the desert heat without turning into a sticky mess. I wipe the sweat from my eyes before it drips onto the work. A drop of sweat on a hot vacuum tube could shatter it instantly due to thermal shock. I am hyper-aware of my body positioning relative to the equipment. My movements are deliberate, almost robotic. There is no room for clumsiness here. A knocked-over jar of water or a bumped table could be a fatal error. I treat the cramped space of the fuselage like a submarine, where every inch is accounted for and every object must be secured. As the sun begins its descent, the light inside the fuselage changes from a harsh white to a deep amber. This is the golden hour, but it brings a different kind of danger. Long shadows stretch across the desert floor, creating hiding spots for anything approaching. I move to the cockpit of the C-119. The glass windows are covered with reflective insulation, but I have left a small observation slit. I use a pair of high-powered naval binoculars to scan the perimeter. The magnification compresses the distance, making the heat waves look like rushing water. I scan the ridgeline first, then the rows of dead planes. Nothing moves except the dust devils swirling in the distance. The stillness is deceptive. I know there are things out there. I have seen the tracks in the morning. I prepare for the night shift. Night is when the radio waves travel furthest, bouncing off the ionosphere to reach the other side of the world. It is also when the temperature plummets. I put on a wool sweater, layering up before the cold sets in. The desert has no thermal mass to hold the heat. Once the sun is gone, it is gone. I switch the radio to the 40-meter band. This frequency is good for night communication. I adjust the gain control, bringing the static floor up. Suddenly I hear a voice. It is faint, buried deep in the noise floor. A rhythmic cadence. I freeze, my hand hovering over the dial. I fine-tune, rotating the knob a fraction of a millimeter. The voice resolves slightly. It is not English. It sounds Slavic, maybe Russian or Ukrainian. It is a number station, reading out groups of 5 digits. I grab my notebook and begin to transcribe the numbers. 5, 2, 9, 1, 0. The voice is monotonous, likely a recording looped on a mechanical tape system. Who is transmitting? Is it an automated failsafe from a dead government? Or is there an active command post somewhere? The signal is strong enough to be coming from outside the continent. This proves that high-power tube transmitters are still operating somewhere. I write down 4 lines of numbers before the signal fades into the atmospheric noise. I do not have the codebook to decipher the message, but the fact that it exists is data. It means the infrastructure of the old world is not entirely gone. I log the time, frequency, and signal strength in my journal. The sun is down now. The fuselage is pitch black. illuminated only by the orange glow of the vacuum tubes and the red LED of my low-voltage warning light. I switch on a small reading light powered by a single nickel metal hydride battery I recharge during the day. The beam is focused and tight, illuminating only the logbook. I hear the wind picking up outside, whistling through the gaps in the airframe. The metal of the plane begins to contract, popping and pinging as it cools. Each sound makes me flinch, my instincts trying to differentiate between thermal contraction and the sound of a boot on metal. I check the stethoscope tubes again. Silence from the underground. It is time for the nickel trick. I need to power the perimeter warning LED without draining the main battery bank overnight. I have a series of plastic cups lined up on a shelf. In each cup, I have placed a stack of alternating nickel coins and pieces of copper wire, separated by cardboard soaked in vinegar and salt water. It is a primitive voltaic pile. I check the connections. The chemical reaction between the dissimilar metals and the electrolyte creates a small voltage. Linked in series, these cups produce just enough juice to keep a single low-power red LED lit. If the circuit is broken, by a tripwire I have strung across the main access ramp, the light goes out. It is a fail-safe. If the light dies, I grab the shotgun. I settle in for the long wait. My eyes are drawn to the output valve on the transmitter again. The crack seems to catch the light of the filaments. It looks like a scar. I know the physics. The glass is under tension from the vacuum inside. Any mechanical shock or thermal spike could cause it to implode. I have wrapped the base of the tube in Kapton tape as a precaution, but it is a psychological bandage more than a structural one. If it goes, I have to attempt a bypass using a smaller driver tube, but that would cut my range from hundreds of miles to maybe 10. I would be shouting into a pillow. I force myself to look away. Worrying about the hardware does not fix the hardware. At 03 hours, the alarm on my mechanical wristwatch vibrates against my wrist. I do not use an audible alarm. I get up and move to the cockpit. I set up the theodolite, an old surveying instrument I found in a geologist's truck. It is purely optical, no electronics. I aim it towards the southeast, towards the restricted airspace of the base. This is the ritual. Every night at this time, the anomaly occurs. I press my eye to the eyepiece. The optics are crisp, gathering the starlight. The runway at the base is dark, of course, but the silhouette of the mountains provides a reference point. I wait. My breath fogs the air in the cockpit, which is now freezing. There. Movement. It is difficult to see even with the optics because the object absorbs light rather than reflecting it. A shape detaches itself from the dark sky and descends. It is a glider, a massive, matte black wing, easily 100 feet across with no fuselage to speak of. It looks like a razor blade cutting the sky. There are no navigation lights, no engine glow, and absolutely no sound. It is not falling. It is flying with purpose. The physics of it disturb me. To generate that much lift at that low speed without a propulsion system implies an aerodynamic efficiency that shouldn't be possible. It descends vertically, settling onto the unseen runway like a feather. I rush back to the radio. The gliders are silent acoustically, but electromagnetically, they leave a footprint. I put the headphones on and crank the gain. There it is. A rhythmic click, click, click. It sounds like a dry sonar ping, or a relay switching open and closed. It is distinct and mechanical. It cuts through the static on the 100 kHz band. This is not communication. It is navigation. They are using a ground-penetrating radar or some altimetry system that pulses. I time the clicks with my stopwatch. Exact 1-second intervals. Precision. Whatever is flying those things is not struggling to survive like I am. They are operating at peak efficiency. The clicking stops as soon as the glider touches down. The silence rushes back in, more oppressive than before. I return to the theodolite. But the runway is empty. The craft has been moved into a hangar or below ground within seconds. This efficiency scares me more than the zombies or raiders the movies promised. You can outsmart a raider. You cannot outsmart a machine that operates with mathematical perfection. I shiver, and it's not just from the cold. I realize I am gripping the theodolite so hard my knuckles are white. I force myself to let go. I am a witness, nothing more. If they knew I was watching, I would be dead. Morning comes slowly after a sleepless few hours. The sun returns, bringing the heat and the wind. The wind is different today. It is gusting, carrying heavier particles of sand. A storm is coming. I can smell the ozone and the dust in the air. I have to seal the fuselage tight. I go outside to retract the solar panels. The mechanism is jammed with grit. I have to force it, using a wrench to leverage the sliding rail. Metal screeches against metal, a sound that sets my teeth on edge. I manage to pull the panels inside the wing root just as the first wall of dust hits the perimeter. The storm hits with the force of a solid object. The C-119 rocks on its landing gear. The sound is deafening, a constant roar of sand blasting the aluminum skin. It sounds like millions of tiny glass beads hitting the hull. Inside, the light drops to a twilight gloom. I turn on my emergency lantern. I check the seals. Fine dust is already puffing in through the seams of the cargo door. I grab a tube of silicone sealant and a caulking gun, fighting to plug the gaps. The air quickly becomes thick and hazy. I tie a bandana around my face to filter the grit. This is the enemy. This dust will scour the lubricants from my generator and coat the contacts of my relays. I retreat to the radio desk. The storm generates massive amounts of static electricity. The antenna is picking up the discharge from the friction of the sand. The radio speaker crackles with loud pops and hisses. I have to disconnect the antenna lead to prevent a voltage spike from frying the receiver's front end. I sit in the dim light, listening to the wind howl. The isolation feels absolute now. I am buried in a metal coffin in a sea of sand. To distract myself, I start organizing my spare capacitors, sorting them by microfarad rating. It is busy work, but it keeps my hands moving. Around midday, the wind shifts slightly. I decide to reconnect the antenna for a brief check, gambling that the worst static has passed. I plug the lead in. The noise is terrible, a roaring static crash, but then underneath the storm noise I hear it. A voice. Not a number station. A human voice. Please, anyone. Air filtration is failing. Sector 4 bunker. Children are... It is a woman's voice, high-pitched, panicked. The signal is weak, fading in and out with the gusts of wind. My heart hammers against my ribs. Sector 4 is only 20 kilometers north. It's a civilian fallout shelter network. My hand instinctively goes to the microphone. I could answer. I could tell them how to bypass the filtration relay. A common fault in those units. I know the schematic by heart. A simple jumper wire across terminals 3 and 4 would restart the fan. I press the transmit button, but I don't speak. I look at the output tube. It's glowing. I look at the frequency dial. If I transmit now, my signal will cut through the storm, but the ghost planes operate out of that sector. If I transmit, I light up their sensors. I am a beacon in the dark. The woman's voice comes again, sobbing now. We can't breathe. Please. I stare at the microphone. The plastic feels cold in my hand. I can save them. I have the knowledge. But the logic of survival is cold calculus. If I transmit, I reveal my location. The gliders might not care, or they might come to silence the noise. I look around my fuselage, my safe haven, the water dripping, the battery charging, the fragile ecosystem I have built. I am one man. They are a family. The math says their lives are worth more. But survival is not about math. It is about fear. I release the transmit button. The click is loud in the silence. I reach out and switch off the receiver. The woman's voice cuts off instantly. The only sound left is the wind screaming outside, sounding like 1,000 voices begging to be let in. I sit in the dark and I do not move. The storm breaks just before dawn. The wind dies as abruptly as if a switch had been flipped, leaving behind a silence that feels bruised. I do not sleep. The image of the radio receiver sitting cold and dark is burned into my retina. I spent the night staring at the dials, fighting the urge to turn it back on, to check if the woman and the children in Sector 4 are still transmitting. But I know the math. Without the fan bypass, the CO2 levels in a sealed bunker hit toxicity within 6 hours. They are gone. I force myself to stand up. Regret is a luxury. Maintenance is a necessity. The fuselage floor is covered in a fine layer of silt that managed to bypass the seals. I grab the broom. The rhythmic sweeping motion grounds me. I sweep the dust into a pile, collect it in a dustpan, and dump it into a sealed bag. I cannot toss it outside yet. The air is still suspended with particulates. I perform the morning system check. The battery bank held its charge better than expected, likely because the radio was off all night. The nickel trick cups are dry. The electrolyte evaporated in the heat of the closed cabin. I will need to refill them with vinegar solution later. I check the main output tube again. The crack in the glass seems to have propagated another millimeter. The thermal stress of the rapid cooling last night likely exacerbated the fracture. It is a ticking time bomb. I gently brush a speck of dust from the glass bulb. It rings faintly, a high-pitched ping that vibrates through my fingernail. It is fragile, holding back the vacuum that allows the electrons to flow. If air gets in, the filament burns out instantly. I need a contingency plan, but my inventory is empty. I unseal the hatch and step out into the blinding Nevada morning. The landscape has changed. The storm has shifted the dunes, burying some aircraft wings and exposing the skeletons of others. The light is harsh, bouncing off the aluminum carcasses. I climb up the ladder to the top of the C-119's fuselage to inspect the solar array. The panels are coated in a thick layer of brown dust. Efficiency is currently near zero. I have to clean them before the sun gets too high, or I lose a day's worth of power. As I wipe the first panel, my eyes scan the horizon. Routine. Left to right. Then I stop. About 3 kilometers to the west, in a sector of the graveyard usually reserved for chopper wrecks, there is a new shape. It is black, angular, and stark against the rusted metal and beige sand. I grab the binoculars. My hands are shaking slightly. Not from fear, but from the adrenaline of the anomaly. I focus the lenses. It is one of the gliders. It is not flying. It is smashed into the ground, its nose buried in the sand near the tail of a deflated Sea Stallion helicopter. It must have been caught in the wind shear during the storm. The craft is remarkably intact, considering the impact. There is no smoke, no fire, no debris field. It looks less like a crash and more like a discarded toy. The wings are swept back, matte black, absorbing the sunlight so completely it looks like a hole in reality. I lower the binoculars. This is a salvage opportunity. Or a trap. The logical side of my brain calculates the risk. If the pilots are efficient machines, they will come to recover it. If they are dead, there might be tech inside I can use. I spend an hour preparing for the excursion. I treat this like a combat patrol. I pack my canvas rucksack, 2 liters of water, a pry bar, a multimeter, wire cutters, and a roll of heavy-duty duct tape. I holster my .45 caliber pistol, old, heavy, reliable mechanical action, and sling the shotgun over my shoulder. I wrap my boots in burlap to muffle my footsteps and disguise my tracks. The heat is already rising, shimmering off the hardpan. I take a final look at the C-119. Leaving the shelter is the most dangerous thing I can do, but the potential reward, advanced materials, maybe an intact power source, outweighs the safety of the bunker. I lock the hatch from the outside using a hidden latch mechanism I welded into the wheel well. The walk is grueling. The sand is soft from the storm, making every step an effort. I stick to the shadows of the aircraft hulks, moving from fuselage to fuselage. I pause every 100 meters to listen. The silence is absolute, save for the blood rushing in my ears. The stethoscope tubes back at base are useless to me now. I have to rely on my own senses. I keep my eyes on the sky, watching for the silhouette of another glider coming to investigate its fallen kin. Nothing. Just the relentless blue void and the sun. I reach the perimeter of the crash site and crouch behind the rusted landing gear of a C-130. I observe the black object for 10 minutes. No movement. No sound. No venting gases. I approach the wreckage. Up close, the glider is unnerving. It is smaller than it looked in the sky, maybe 15 meters wingspan. The material of the hull is not metal. It feels cold to the touch despite the desert heat. It has a texture like shark skin. Smooth one way, rough the other. I tap it with the handle of my knife. It doesn't clang. It thuds, a dull, dense sound like hitting a bag of wet sand. There are no rivets, no seams, no weld lines. The entire craft appears to be a single continuous piece. I move to where the cockpit should be. The canopy is opaque, black glass that has shattered not into shards, but into a web of fibrous strands, holding together like safety glass but flexible. I use the pry bar to leverage the canopy open. The material groans, a wet, tearing sound that makes my stomach turn. It smells inside, not the chemical smell of burnt aviation fuel or hydraulic fluid. It smells like a butcher shop. Copper, iron, and something muskier, like damp earth. I shine my flashlight into the cockpit. It is empty. There is no pilot. There is no seat. Instead, the interior is lined with a ribbed, gel-like substance that looks like muscle fiber. Hanging from the ceiling are cables, but they aren't copper. They are translucent tubes pulsing with a faint bioluminescence. The controls are just indentations in the gel, molded to fit something. I lean in further, my engineering brain trying to make sense of the biomechanics. There is no instrument panel, no dials, no gauges. Just a central console where a cluster of these translucent tubes converge. In the center of this convergence is a module. It is the size of a car battery, encased in a dark amber-colored resin. It is pulsing. A rhythmic, slow throb of light, dim violet, emanates from its core. I bring my multimeter close. The needle jumps wildly before I even touch the probes to anything. This object is generating a massive electromagnetic field, but it's contained, structured. It's not a battery, it's a generator, or a processor, or a heart. I need this. I don't know what it is, but I know it holds energy. I take out my wire cutters. I hesitate. Cutting into this feels less like salvage and more like surgery. I select one of the input tubes. I clamp the cutters down. It offers resistance, rubbery, and tough. Snip. A spray of bluish fluid hisses out, hitting my glove. It sizzles slightly but doesn't burn. The pulsing of the amber module speeds up like a panicked heartbeat. I work faster, severing the remaining connections. With each cut, the hum of the machine drops in pitch. The glider is dying. I grab the module with both hands and pull. It comes free with a wet suction sound, trailing severed filaments. The module is heavy, maybe 15 kilos. It is warm, radiating a heat that feels biological, like holding a feverish child. I shove it into my rucksack, wrapping it in a spare canvas tarp to contain the glow and the fluid. I check the crash site one last time. There is nothing else recognizable as technology. No radio, no weapons. The glider itself seems to be decomposing rapidly now that the core is removed. The black skin is turning gray and flaking off like dry ash. I have to leave. The smell of the fluid is strong, and in the desert, smells travel. Scavengers, coyotes or worse. We'll be here soon. The return trip is a blur of paranoia. The weight in my pack shifts with every step, thumping against my spine. I feel a phantom prickling on the back of my neck, the sensation of being watched. I keep scanning the sky, expecting to see a black shape diving at me. The heat is at its peak, 45 degrees Celsius. My water is low. I force myself to keep a steady pace, not running, not panicking. Running wastes water. Running breaks ankles. I make it back to the C-119, scramble up the ramp, and lock the hatch behind me. I collapse against the cool metal of the interior wall, gasping for air, clutching the rucksack to my chest. I take the object to my workbench. Under the stark light of my desk lamp, it looks even more alien. The amber resin is semi-transparent. Inside, I can see intricate structures, lattices of gold filament suspended in a dark liquid. It looks like a vacuum tube designed by nature. I clean off the blue fluid with a rag. The pulsing has stabilized to a slow, steady rhythm. I bring the Geiger counter close. No ionizing radiation. That's a relief. I switch the multimeter to resistance mode and touch the probes to two of the severed filament stumps protruding from the base. The meter reads 8 ohms. Stable. I try two others. Infinity. It has a circuit logic. I spend the rest of the day mapping the pinout of the artifact. It has 8 primary connection points on the base, arranged in a circle with a central guide key. My breath catches in my throat. I grab a spare octal socket, the standard 8-pin socket used for 6L6 or KT88 vacuum tubes. I hold the artifact over the socket. The spacing is identical. It's not just similar, it is a perfect match. The realization hits me with the force of a physical blow. This isn't alien technology. Or if it is, it was designed to interface with our technology, specifically, our analog technology, the Cold War era tech. It fits the infrastructure we abandoned. Night falls, and the temperature inside the fuselage drops. I am exhausted, but I cannot stop staring at the thing. It sits on my bench, glowing faintly. I decide to call it the heart. It is clearly an amplifier or a power source. I look at my radio transmitter. The cracked output tube is still holding, but the glass is cloudy. It's dying. I have a choice. I can keep using the dying tube until it fails, or I can try to integrate the heart. But the risk is catastrophic. If the voltage pinout is wrong, I could fry the entire transmitter. Or worse, the artifact could overload and explode. I try to sleep, but the silence of the bunker is disturbed by a new sound, A low-frequency hum, barely audible, coming from the workbench. The heart is singing. It resonates with the metal of the table. I toss and turn on my cot. I dream of the black glider, of the muscle fibers turning into snakes, of the woman's voice on the radio asking for help. I wake up in a cold sweat. It is a 3:00, the time of the ghost planes. I go to the cockpit, check the theodolite. The runway is empty. No gliders tonight. Are they searching for the lost one? Or do they know exactly where it is? I return to the radio. I turn it on to check the morning traffic, just habit. The receiver warms up. Static. Then, a loud pop. A flash of blue light from the back of the chassis. The smell of burning dust. I kill the power instantly. My heart sinks. I pull the cover off the transmitter. The output tube, the one with the crack, has finally shattered. The glass lies in shards inside the cage. The filament is broken. It is over. My voice is gone. I stare at the broken glass. I am mute. I can listen, but I can never answer. The isolation instantly feels 10 times heavier. This is it. The universe has forced my hand. I look at the heart sitting on the bench. It pulses, as if it knows. I have no other tubes. I have no other choice. If I want to transmit, I have to use the biological component. I clear the workbench. I need to prepare the socket. The heart's pins are soft, like cartilage. I can't just plug them in. I need to ensure they make electrical contact without rotting the metal socket. I coat the socket receptors with a conductive silver grease I scavenged from a radar station. This will bridge the gap between biology and metallurgy. I check the voltage rails of the transmitter. The plate voltage is 600 volts DC. That is enough to kill a man, and certainly enough to cook biological tissue. But the heart was generating its own field. Maybe it feeds on voltage. I solder a fuse holder in line with the main power supply, a 2-amp fast blow fuse. It is my only safety net. If the heart draws too much current, the fuse blows before the transformer melts. I am trembling. This is engineering heresy. I am splicing a wet, living thing into a dry, high-voltage circuit. I lift the heart. It feels heavier now. I align the soft, organic pins with the holes in the octal socket. I press down. It resists at first, rubbery and stubborn, then slides in with a wet squelch. The fit is tight. The amber resin sits flush against the steel chassis. It looks grotesque, a pulsating organic tumor growing out of a 1950s piece of industrial electronics. I wipe my hands on my pants. They are slick with sweat. I double-check the wiring, ground to ground, plate to plate, heater. Well, I don't know which is the heater, so I guessed based on the standard pinout. I step back. My hand is on the main power switch. Here goes nothing, I whisper. The sound of my own voice startles me. I flip the switch. The power supply hums, the familiar 60-cycle buzz. I watch the fuse. It holds. I look at the heart. For 3 seconds, nothing happens. Then the liquid inside the resin begins to swirl. The violet light intensifies, shifting to a blinding white blue. It doesn't warm up slowly like a vacuum tube. It ignites. The hum from the radio changes pitch, becoming a harmonious chord, like a choir holding a single note. The needle on the power output meter slams to the right. It buries itself past the maximum rating. I reach to cut the power, fearing an overload, but the needle drops back and stabilizes at 100%. It is self-regulating. The efficiency is impossible. A standard tube wastes 50% of energy as heat. The heart is cool to the touch. It is converting every watt of input power into RF energy. I put on the headphones. The static floor has dropped. The silence is crystal clear. The signal-to-noise ratio is perfect. I grab the microphone. My hand shakes. I need to test the SWR, standing wave ratio, to make sure the antenna is actually radiating the power and not reflecting it back. I key the mic. Test, 1, 2, 3. The SWR meter hardly moves. A perfect match. The antenna is radiating everything. But then I notice something on the frequency display. I am tuned to 14,200 Mauser-Mertz, but the dial is drifting. The radio is tuning itself. The knob physically turns under my fingers, fighting my grip. It stops at 100 kHz. The VLF, very low frequency band. The band of the gliders. I fight the knob, forcing it back to the voice band. The resistance is physical, like arm wrestling a child. I get it back to 7,000 MHz. I key the mic again. This is station Sierra 19er, blind broadcast. Is anyone receiving? I release the button. The speaker erupts, not with static, with voices, hundreds of them, overlapping, screaming, talking, whispering. I am picking up everything. The sensitivity is terrifying. I hear a conversation in Spanish, a military report in Mandarin, a crying child in English. The range is global. The heart is not just an amplifier. It is a quantum antenna. I am overwhelmed. I scramble to turn the volume down, but the voices persist in my head, buzzing in my teeth. The RF field in the room is so strong I can taste metal. I look at the fluorescent light fixture on the ceiling. It is glowing, even though the switch is off. The ambient energy is ionizing the gas in the tube. I am sitting inside a microwave oven. I have to shield this. I grab a roll of aluminum foil and hastily wrap the chassis of the radio, trying to create a Faraday cage. It dampens the effect slightly, but the voices in the headphones remain clear. I isolate a signal. It is strong, clear, and coming from the East Coast. Repeat. This is the USS Nebraska, submerged on station. We are detecting a massive signal spike from grid sector Sierra Nevada. Identify yourself. Over. A submarine. An active nuclear submarine. They heard me. I just blasted a signal across the entire continent with a scavenging rig and a piece of dead alien biology. I stare at the mic. If I answer, I confirm my position to the most powerful military remnant left on Earth, and they will want what I have. I do not answer the submarine. I tune away, hands shaking. I need to understand what this thing is doing to my equipment. I look at the modulation scope. The waveform isn't a sine wave. It's jagged, recursive, almost fractal. It looks like speech. Even the carrier wave looks like it has information encoded in it. I realize with a jolt of horror that the heart might be transmitting data I am not aware of. Is it a beacon? Have I just turned on a homing signal for the entire fleet of black gliders? I reach to pull the plug, to kill the transmission. As my hand nears the power switch, a spark arcs from the chassis to my finger. It stings, burning a small black dot into my skin. It defended itself. I try again, using a rubber-handled screwdriver to flip the switch. The switch clicks off. The lights on the radio stay on. The heart is glowing brighter. It is powering the radio itself. It has reversed the flow. It is no longer drawing amps from my batteries. It is feeding energy back into the system. My voltmeter on the wall climbs. 13 volts, 14 volts, 15 volts. Panic sets in. I run to the battery bank and rip the alligator clips off the terminals. Sparks shower the floor. The radio stays on. The heart is self-sustaining. It is pulling energy from somewhere else. 0-point energy, the ambient static, or the heat of the room. It is violating the laws of thermodynamics. I back away to the far wall of the fuselage. The radio sits there, humming that choir note. The voices from the speaker now a low murmur of global humanity. It is beautiful and terrified. I have invited a monster into my home. I grab the fire axe from the wall. Basic physics. If you can't cut the power, you destroy the machine. I raise the axe, aiming for the amber bulb. I am breathing hard, sweat stinging my eyes. The heart pulses faster, the light turning a violent red. The speaker volume spikes, emitting a screech that sounds like a modem handshake mixed with a human scream. It freezes me. The sound is not coming from the radio. It is coming from inside my head. It knows. I lower the axe. I can't do it. It's not just a machine anymore. It's a pet, and it's the only thing keeping me connected to the world. I drop the axe. The light fades back to a soothing violet. The hum returns to a lullaby. I sit on the floor, watching it. I am no longer the operator. I am the host. I have lost track of time. My watch has stopped. The mainspring magnetized by the field generated by the heart. The environment inside the C-119 has changed physically. The heat is gone. The fuselage is now freezing. Condensation freezing into frost on the aluminum ribs. The device is not just efficient, it is endothermic. It is sucking the thermal energy out of the air to power the carrier wave. I am shivering, my breath pluming before me in thick white clouds. But I cannot leave the desk. The wires connecting the heart to the radio chassis have changed color. They are no longer copper-colored. They have turned a bruised purple, and the insulation looks like stretched skin. The boundary between the machine and the biology is dissolving. I have become a component in the circuit, the organic ground for a signal I do not understand. The seismic detectors are screaming. The stethoscope tubes hanging on the wall are thrashing like dying snakes as the ground outside vibrates. It is not the subtle click of a footstep anymore. It is a continuous harmonic tremor. I force myself to stand, my joints stiff from the cold, and move to the observation slit. The view is impossible. The boneyard is no longer empty. A circle of the black gliders has landed around my fuselage. 12 of them. They sit motionless in the moonlight, their matte surfaces absorbing the shadows. They are not attacking. They are waiting. They are arranged in a perfect radial pattern, acting as a passive directional array to focus the signal emanating from my desk. I return to the radio. The frequency dial is spinning on its own again, faster this time, blurring the numbers. It stops abruptly at a frequency that shouldn't exist on this equipment. $0,000. Direct current? No, it's a null carrier. The noise in the headphones ceases completely. Then, the synthesis begins. The radio is no longer picking up voices from the world. It is generating a voice. It is my voice. Coordinates locked. Vector confirmed. Uploading local telemetry. It sounds exactly like me, but flattened, stripped of all cadence and emotion. It is a digital ghost constructing itself from my vocal patterns. I try to touch the volume knob to lower it, but a shock of static electricity throws my hand back. The air smells of ozone and iron. The realization hits me with the clarity of a schematic diagram. I am not the survivor here. I am the patch. The biological component I salvaged, the heart, was damaged when I cut it from the crash. It lost its interface. It needs a biological bridge to complete the circuit, to regulate the impedance match between the alien power and the terrestrial broadcast. I look at my hands. The veins are standing out, pulsing in time with the violet light of the tube. I am the variable resistor. I am the bypass I spent my whole life building. The gliders outside aren't here to rescue the component. They are here to collect the transmission that the component can only send through me. The cargo hatch at the rear of the plane begins to open. I did not unlock it. The hydraulic actuators whine, powered by the induction field filling the room. The ramp lowers slowly, grinding against the frozen desert hardpan. The wind howls in, carrying the dust, but the dust doesn't settle. It hangs suspended in the air, caught in the electromagnetic static. I should be terrified. I should be reaching for the shotgun, but the logic of the engineer takes over. Fear is just a reaction to lack of data. I have the data now. The equation is balancing itself. I turn my chair to face the open ramp. The night sky is framed there, vast and full of stars. A figure enters the ramp. It is not human, but it is not one of the pilots. It is a suit, empty and rigid, moving with the jerky precision of a marionette. It is a containment suit, similar to high-altitude flight gear, but made of that same light-absorbing material. It stops at the bottom of the ramp. It is waiting. The radio voice speaks again, booming through the fuselage. Interface required. Signal degradation imminent. Reroute via biological node. The command is for me. The gliders cannot touch the radio. Their biology is incompatible with this crude copper and glass technology. They need a translator. They need a signalman. I stand up. My legs feel light, disconnected from the gravity of the earth. I look at my workbench one last time. The soldering iron, the half-eaten can of peaches, the logbook, the detritus of a man trying to survive the end of the world. It all looks so primitive now. I understand why the EMP happened. It wasn't an attack. It was a format, re-initialization, a reboot to clear the noise so the real signal could get through. I walk toward the open hatch. The cold doesn't bother me anymore. The humming in my head has synchronized with my heartbeat. The tinnitus is gone. There is only the signal. I pause at the top of the ramp. I look back at the radio. The heart is blindingly bright now, a miniature star captured in glass and resin. The output tube I replaced, the biological one, is pulsing rapidly. I speak one last time, not into the microphone, but into the air. Log entry final. Calibration complete. The schematic is corrected. The flaw was not in the hardware. It was in the isolation. We were never meant to be receivers. We are the transmission. I step onto the ramp. The suit at the bottom raises a hand, not in greeting, but in reception. I walk down to meet it. The darkness of the Nevada desert swallows the light of the fuselage. Vector, zenith, azimuth, elevation, infinite, packet loss, 0. The vessel is discarded. The frequency is pure. Repeating coordinates for extraction: 379.111. Null. Repeating: